Hi everybody, this is MRK and welcome to my next video, which is about fog. In the previous video we were talking a little bit about Strata and experimenting with it. And I told you that I was making a fog using that system. So here it is. So what is this fog? It's basically a way to make placeable fog. So here you have a sphere and in the center of it you have some fog. And you can duplicate it, change its size, and it will adjust. So you can make nice clumps of different sizes, and it gives more power to the level designer to make the scene feel more organic than just using the default volumetric fog that just spills fog everywhere. And this system is also based on that volumetric fog, but it needs some adjustments. First of all, it doesn't work without volumetric fog. And second of all, you still use it, but you use it on a very low values. And I know it sounds very weird right now, but let me explain. So first you need exponential height fog to be placed on the map. Then you bring fog density down to 0.001. At least that's the value I found working. You can of course go lower, so 0.001, but it's important to keep it above 0. Otherwise it will just not work. It will just be black, so no fog. And if you make it, let's say 1, then the fog just makes cubes and completely ignores the masks. And on lower values, still almost the same. 0.001, yeah, still the same. So it has to be really low value. On 1000, it's almost working, but yeah, 3 zeros after that is what needs to be what needs to be done for this to appear nicely. And second thing you need to enable is volumetric fog. So click that, set this to that value, and you're pretty much set. And you can make your material. So let me present some parameters. Basically, this is a material instance that I have here. And this is Strata volumetric test instance, and we can add, not add, modify values in runtime. So we have those fogs, and you can see I added a few different things. Basically my system uses panner, 3D panner, because this is volumetric and normal panner is just 2D. So this basically moves the fog. We can increase the value and make it faster, so something like a steam vent. And of course we can decrease the value to 10, and we'll just slowly move up. I leave it at I think 100 was fine, because it moves not too fast, but it's not rushing too much. Of course you can change the color of the fog. Let's leave it at 1.1. And we have some other things that you can use to modify the fog. So a hardness mask, if you put it to 1, then it fills the sphere. I leave it at 0. And softness, which is almost the same, but it doesn't have that hard edges. And if you make it 0, it's just trippy. It's just fucking nuts. Let's try 0.1 maybe. Let's see. Actually didn't experiment that much with it. It's fun. 1. Yeah, 1 is just hard edge, and 0 is trippy. How about minus values? Okay, we got clouds. I didn't see that coming, but I guess it inverts the noise I'm using. So on 10 it's... Actually, let's test this because I have invert noise here. Let's invert. Yeah, it's totally using it's totally inverting the noise. So that's what it's doing. Let's leave it at 10K because we want a nice smooth fog for now. And noise size, so how big the clamps are. We can decrease it to make it very, very grainy, or increase it so we have basically patches, right? So this is how it works. Filter width is the smoothness also, but in a different way. If you make it 0, then the noise basically doesn't come, the noise comes through, and if you increase it to 1, it doesn't, right? So let's make it 0, so we want to let through everything. And let's dive behind the scenes, how the system works. Okay. So first thing first, you can of course do this in normal material nodes, but you can, if you are working in Strata, then that's how you do it. You basically use the Strata Volumetric Fog Cloud BSDF, and it automatically picks the right domain and blend mode. And if you're not working in Strata and you have normal nodes, then you have to pick volume and additive. If you pick anything else, then it will just tell you to use additive. And yeah, you have the same nodes that you have in Strata. Where is it? Albedo, extinction, emissive color, ambient occlusion, and yeah, this is basically the same thing. But I see now that ambient occlusion is duplicated for some reason. I don't know why, but whatever. So you just have those two nodes combined, and you have to set appropriate domain and blend mode, and you're good. So for color, I don't use albedo because it doesn't work for me. Nothing shows, but maybe it will work for you. You can experiment and see. But anyway, I am using emissive color and it works fine, so I'm gonna stick with that. This is just a color parameter that you saw here, and you can change color of the fog. And for extinction is all of the code basically of that. So it's not super complicated, but it has a few nodes, so let me get through those. Basically, we need a sphere mask. Sphere mask, what it does is basically masks a sphere or anything but the sphere. So our default rendering method for that fog is of course cube, as you saw before. And if we want to make a sphere, then we have to use a sphere mask. So how sphere mask works, basically B is a center of the sphere, so we take an object position. It also works with actor position, but object position is, I guess, safer because it doesn't take into account materials. So it's a pure center, pure origin of the actor or the object. And the absolute world position is basically the rendered pixel. So we plug it to A. It's a point we check against the center. Then we pick radius, is basically object radius. It picks the object radius and a parameter for hardness. I left it as 0.5, but yeah, if you want to do what I did, is you can just leave it as 0. I think if you don't plug it in, then it is also 0, but didn't test it. Then we have a reroute node. If you don't know what that is, it's I think a new feature in 5.1 or 5.0. I did not use 5.0 for very long, honestly. So it may or may not be there. And how you do this is basically you type route named reroute declaration node, and you pick a name. For this purpose, I picked sphere mask. I'm not gonna make another because we have one here. And if you want to use this, then you just use sphere mask reroute, and you have an output. So very nice organizing thing. I don't know why is this not a thing in blueprints, but maybe they will add something like that in the future. I would very much like that, because this is a great thing and it cleans the code in a very nice way, in alternative way to using just normal root nodes, right? Because it's still using those noodles, right? And some people don't like noodles, and if you have too much noodles, you will make a spaghetti. And sometimes we just want things to work and don't want to cook spaghetti. Right? So let's remove that. And named reroute nodes, very nice. Second thing we need is a panner. We could use a normal panner that comes with the engine, which is called, surprise, surprise, panner. But the problem with this panner is that it's 2D, because materials usually are 2D. So usually it's all you need, but in this case we need a 3D panner. So what panner does is basically this. So you take time, multiply by a value you have here, so speed, and that's panner. That's all it is. And if you want to make a 3D panner, then you have to use 3 values. In this case, we make a float 3, and we make X, Y, and Z. Z being, of course, up and down. So yeah, if you wanted to, you could also make a 4D panner, but we live in a 3D world, so it's kind of hard to say what that 4th dimension would be. But you can, and you can use it for something. Just make float 4 instead of 3, and just add another parameter and call it panner W, because that's the fourth variable. 4th dimensional variable, I guess. And you plug it in, and you can make a panner in 4th dimension. Okay, but we don't need 4 dimensions, we just need 3, so this panner is fine. And we come to the base code that goes into extinction. Basically, first we use a noise. You can use volumetric texture, that's no problem. I can't type volumetric Or is it not called volumetric texture? I actually don't know. Got kinda lost. But if you pick texture sample, wait, it's not 2D. That thing I know. It's not param 2D. I think I used that at the very beginning, but I didn't have volumetric texture, so I just scrapped it. How was it called? Texture sample parameter volume. That's exactly what it is. And you can call it volume texture. And it's instead of that noise, you can just use volumetric texture or volume texture. But you have to have a texture, which which I don't, so I just compute stuff myself. So yeah, we pick absolute world position, so position of a pixel. We get our panner, we add those two together, so they move up and down. Then we divide those, this value by the noise size. Sometimes my tongue is just going crazy. And we plug this to position. And position controls how grainy or how patchy the noise is. And in filter width, we just plug a normal scalar value. It's just a filter width between 0 and 1. You can read what exactly is this. But it doesn't really say it in that note. But I told you before, it's like imagine a normal filter, like a water filter or a grain filter, and basically how large the holes are is the value here. So if the holes are large, then you make you let more noise through, or whatever value is plugged in here. In this case, it's noise. So if we pick value 0, then actually it's reversed, I guess, because if it's 0, then you let through everything. But I guess you can think about it in different ways. Then you have inverted noise. This I added because you can have two distinct ways to render that noise. And the first way is very cloudy. Like, I don't mean cloudy, but it looks like clouds in the sky. And the second way is the way you saw here. So it's very foggy, and the clumps are joining together nicely. So if you invert it, I would use it for fog. If you don't invert it, I would use it for clouds, basically. Then you take the sphere mask, you multiply it by all of that. And then you have softness, so you divide it by a value. You make it smaller, darker. And so it's more softer if you divide it. And you plug it to extinction. And that's basically it. The fog is done. And then you make a material instance, put it on a sphere. So just make a sphere. Bam, we have a sphere. You put it here. And you make it larger, and you have a fog. That's it, basically. One, of course, downside of all of that is that you can't use fog, like normal fog, anymore. Because we are using the exponential height fog, and we are bringing the fog density very, very low, but we are still using that exponential height fog. So if we wanted to use it, we would have to crank it up, but that would destroy the effect we were going on here. So, well, shit happens. Sometimes you can't have everything, sometimes you gotta decide, but maybe for your project it's better to just have a placeable fog. And, you know, level design a very specific scenarios where the fog isn't everywhere, but in some patches, just somewhere, right? Okay. One thing maybe I wanted to say before, let's see before I end the video. Yeah, I didn't show you the inverted or the normal non-inverted way. So let's turn this off and see how it looks. So as you can see, it's more cloudy. It's no longer connected to all the other clamps, but it's more like free falling or flying up, loose patches of fog that are not connected with other neighbors. So that would be great for fogs if you wanted to do that. But of course you have to, you know, change the panel, so you're not going up and down, you're rather going in X or Y direction. Let's do it like that. Right, so the clouds are going left to right, or forward backwards if you want. And you would of course have to bring the softness down to 1000, for example, so you have nice visible patches, and play with other values like noise size, so the patches are bigger. And you would have a nice cloud system. Of course, if you're not using the cloud system already in the engine, like I am using, because I mean you totally can. It's called volumetric cloud, and yeah. But if you are making a very cartoonish game or a very stylized game that needs to use some custom fogs, then custom clouds, of course, then you can totally use something like that and place those clouds in specific parts, and it would look very nice. And you could, of course, go through them. So I think that's it for this video. I hope you learned something. I hope it wasn't too boring. In the next video, I think I'm gonna show you some things from blueprints already, because blueprints is actually what I'm best at. Sorry about that. I hit my microphone. Blueprints is what I'm best at. Materials, I'm honestly just learning and finding out cool things like this fog, and I'm telling you guys. So next videos, more blueprints, more actual coding, let's say. And yeah, hope you enjoyed, and till the next video, bye bye.